Good morning, everyone. Thank you all for joining this webinar today. My name is Vincenzo Belletti. I am the Innovation Policy Manager here at Sesimo, and it's my pleasure to welcome you today to this webinar organized by Sesimo on additive manufacturing, an opportunity to fill the gaps in the traditional supply chain. Our panel of experts have an important topic to discuss ahead. And before handing over the word to Stuart Lane, Corporate Manager at Renishaw, and also Chairman of the Additive Manufacturing Committee here at Sesimo, please let me share with you some information about this webinar. If you have a question, you can address them directly to the speakers through the Q&A section or through the chat. Please make sure to specify the name of the speaker that you would like to answer your question. You can also make sure that we will also make sure that the presentation are shared with you after the end of this webinar. With no further delays, I would like to give the floor to Stuart, and I wish you all a pleasant webinar. Thank you.
Thanks very much, Vincenzo. I'd just like to welcome everybody here today. Thank you to the attendees and indeed to our expert speakers. You're going to hear from me a short presentation on the subject matter today, and then we will see presentations from each of our expert speakers, and afterwards we will have the opportunity to put your questions to them, and then if we have time at the end, there will be a brief summing up. So I hope that you find today's session interesting. It's a bit of a first for me. Let's hope it goes well. Right. Okay. To start with, I'd just like to introduce Sesimo to those of you that haven't heard from us. We're an umbrella trade organisation representing 15 national trade bodies from within and outside of the European Union, established in the 1950s and based in Brussels. We represent the common interest of the European AM sector, hence today's webinar, as well as the machine tool industry and related manufacturing technology industries. And that's both at an EU and also a global level. Sesimo helps European industry to maintain and improve global competitiveness through the sharing and coordination of expertise in subjects such as global trade, legislation, technology, leadership and innovation. In recent months, Sesimo instigated some initiatives aimed at unlocking the potential of the Additive Manufacturing Centre in the support of hospitals and their fight against the COVID-19 pandemic. We launched a call to action which resulted in the participation of over 200 companies, all willing and supporting the manufacture of critically needed equipment at the height of the pandemic. And I think many of you are already aware of the case study involving parts for ventilators in Italy, and also the many people using plastic printing machinery to make parts for visors and masks for people in the healthcare industry. While working together with those companies, we saw firsthand some of the challenges that they face when wanting to help. And it was based on this experience that Sesimo developed a list of recommendations for European policymakers aimed at addressing some of these matters, which included keeping the AM sector on the list of essential value chains that should continue its activities during the lockdown period. The discussions that we had with industry at that time also gave us the opportunity to focus on different matters that are currently blocking, as we see it, growth of AM business, growth of the AM sector in Europe. And those revolve around, there we go, production capacity, regulatory and non-regulatory barriers, funding from R&D to production, we'll touch on that in a bit, patents, licensing, IPR, standardization, certification, and skills shortages. And it's through this experience that we as an organization have taken it upon ourselves to do what we can to try and tackle these issues through our work groups, publications, lobbying and awareness events. Today's webinar will focus on how to use AM to make businesses and their supply chains more resilient and mitigate risks caused by sudden disruptions like the COVID pandemic. As Europe moves past the most acute phase of the pandemic, and I genuinely hope that is the case, and we start to look at our recovery plan, many businesses are having to look at the reliability of their supply chains and also to mitigate risk. And as we know, our supply chains are only as strong as their weakest links, and some of those weaknesses, in my opinion, at the moment are being sorely tested. Beyond the immediate need for supplies, questions are being raised about the risk inherent in our various supply chain structures. Over decades, our supply chains have globalized, they've specialized, they've become cost effective, but this does expose business to risk in the case of, shall we say, a breakdown in cooperation. And the supply chain disruption is hard to predict. Many companies are going to have to rethink their approach to try and maintain their operation. Using AM could support traditional supply chains during times of need to give flexible and on-demand solutions, as we saw during the pandemic, and allowing for a substitution of parts as well as on-site production of critical items. Which takes me on to my next slide, thank you, Vincenzo, which is how, in my opinion, should a company look at adopting AM into their supply chain. Well, I think, first of all, the magnitude of disruption of supply chain depends on a company's specific context and the characteristics of that supply chain. We think that you need to look back over it, identify the areas of risk to your business, look at your current sourcing strategy and see where AM could fit in. But the priority should be based on criticality of supply to your business. We're no longer talking about product design and application for AM here. We're talking about business criticality. And I also think in terms of evaluating AM and its fit for your organization, you need to partner. It's becoming a well-established technology. There are experts, organizations, institutions out there who can support you, so you don't need to repeat work that someone else has already done. And also, please take note, and Vincenzo asked me to make a special point about this, there is funding out there, and there is EU funding out there for companies who wish to implement changes to their supply chain, looking at new solutions to make a more resilient European industry. And thirdly, on this slide, while justifying the investment, the recommendation is really look at the overall benefit of AM to your organization and supply chain. Look at the value of the investment as an insurance policy. These are uncertain times, and the lowest unit cost of something soon becomes expensive if you can no longer buy it. In recent years, AM has moved beyond a prototyping technology to something that can be integral in a company's supply chains and their own manufacture. And I'd like our speakers today to discuss more about how this can be a viable solution for bridging the gap in a company's supply base. So we have 4 excellent speakers for you today. I won't go through their biographies now. Yeah, I think you've all got the opportunity to read them. We have Lorena Ionita from DG Grow European Commission. Welcome. We have Fabio Annunziata, Global Head of Strategy from HP for 3D printing, digital manufacturing. Bernard Muller from the Fraunhofer on the AM Manufacturing Alliance. And finally, Vincent Veniger from Managing Director of Ramola, and indeed an entrepreneur. Vincenzo, can I hand over the floor to Ms. Ionita, please?
Good morning. Good morning, everybody. Many thanks for for the invitation to this webinar. So I'm Lorena Anita, I'm the Deputy Head of Unit of the Unit Industrial Strategy and Value Chains in DG GROW in the European Commission. And I have a few slides. I will go quickly through them because I think I'm only allocated 10 minutes. And it will be about the industrial strategy, but in the new context of the recovery. And I will try to point out throughout the slides the issues which are more relevant for the AM sector. So we can already start and go to the next slide. Well, the first slide is just a recalling of what are the key priorities of the industrial strategy from 10th of March. What we see with the crisis and now with the recovery plan that the Commission issued on 27th of May and of which I will also speak, is that we see not only confirmation that the priorities from the March industrial strategy are still valid, but on the contrary, we see a need to accelerate these priorities and put them faster into practice. And these are especially linked to the green transition, to the digital transition, and the global competitiveness. And we see now the recovery as an opportunity not only to repair the short-term damage from the COVID crisis, but also use the recovery as a transformative process and accelerate the digital and the green transitions of the European industry. And I know Sesimo is also keen in seeing a quick delivery and implementation of the industrial strategy. We can go to the next slide. Thank you, Vincenzo, because I don't have a possibility to. Thank you. On this one, I will go quickly. This is again from the industrial strategy. It's they are the 7 fundamental factors in making Europe's industrial twin transformation happening. Here, I will only point to the single market. The crisis again has shown us how important a well-functioning single market is, and I think the AM sector already also seen it because you stepped in through this call for manufacturing the critical medical supplies. So you have seen also in this involvement in the COVID crisis how important was that the single market functioning and that there is a quick matching of supply and demand and the value chains that should work. We can go to the next slide. Thank you. Now, on the industrial ecosystem, this is a concept which was already put into the industrial strategy from March. Basically, the industrial ecosystem brings together all the players in a value chain, whether it's large company, SMEs, service providers, suppliers, public authorities, research community, academia, and we have also worked with this concept of the ecosystem during the crisis, and now I will speak about the recovery plan and also in the context of the recovery plan. Why this is important? Because we have seen from the crisis how important, how interdependent member states are in the single market and how important the value chains are in Europe, because if parts of the value chain, they are spread all over geographically, they can be in any country, and if parts of the value chain do not function, for instance, if there is a factory stopped in Hungary or in Poland, the whole ecosystem cannot function. So we have seen with the crisis how important is that the value chain and supply chains function well, and the concept of industrial ecosystem capture well these interdependencies in the value chain and among member states. And we have continued to, as I said, to work with this concept concept in the recovery phase. We have actually, I will speak about it later, but we have identified 14 industrial ecosystems, which represent 90% of the business value added in Europe. And some of these ecosystems are very relevant for the AM sector. And we will continue going ahead in the recovery to work with this ecosystem and to finance projects throughout, in this ecosystem, and the AM sector will be able to benefit of all these funding possibilities. And some of these 14 ecosystems are very relevant. For instance, whether it's energy, construction, aerospace, health, automobile and mobility. So these are very relevant for, and digital, these are very relevant for your industry. Okay, we can go to the next slide, please. Now, as I already mentioned the recovery package from 27th of May, and we came up with this recovery package against a certain assessment of the economic situation. We all know that this is an unprecedented economic shock with a sharp drop in GDP. And we have calculated the repair and the investment needs during the recovery period. So we have seen significant equity repair needs in the range of 720 billion to more than 1 trillion in 2020 due to financing shortfalls for companies. But we have also calculated and assessed the investment gaps, whether it's caused by the crisis, but also which is needed to deliver the medium to long-term goals in terms of green and digital transformation, and in terms of strengthening critical value chains. We have seen actually that although the shock was symmetric, that the recession risks to be asymmetric among member states, because this depends on the economic structure and the capacity to absorb and respond to economic shocks of each member states. So it is important now to ensure a symmetric recovery, and that's what is the aim of the recovery plan. We have also seen the deep interlinkages between EU economies, and I already mentioned the interlinkages between value chains, and we have seen that all industrial sectors rely on complex value chains, which are spread across several member states. And we have seen from the previous crisis, the financial crisis of 2008-2009, that we need reforms, and we need especially investments for a long-term recovery. So now there is a huge financial package which is put on the table by the European Commission on 27th of May, with the key being investment projects. We can go to the next slide. Okay, so this is I already mentioned the recovery plan from 27th of May, which has 3 pillars. First is supporting member states to recover, repair, and emerge stronger from the crisis. And the member states will have to draw national recovery plans. And the aim is to support especially the twin digital and green transition. So basically these recovery plans should have in mind some medium to long-term objectives of the industrial transformation for green and digital purposes. And the second pillar is especially And this national recovery plan will be actually all the priorities there will be investments will be financed through the recovery and resilience instrument. The second pillar is about kickstarting the economy and helping private investment. This will be done via loans and equity, in particular through a solvency support instrument to help the recapitalization of companies that are most at risk. Secondly, we have made changes to the Invest EU program, partly to increase the investment in sustainable infrastructure to speed up the green transition. And secondly, we have created a new, what we call window, a strategic investment facility to support the resilience and the strategic autonomy, and but I will have a separate slide about that. And third pillar is learning the lessons of the crisis, and among these is especially a new health program which draws the lessons from the COVID-19 pandemic. Through all so there is a lot of money on the table. We have seen the so the table, small table on the right hand side shows you the 540 billion that is, which was already agreed during in the middle of the crisis. And we have a Next Generation EU program, which is the new instrument put forward with the recovery plan on 27th of May, which is of 750 billion. And a big part of it will be also grants. And we also have a revamped MFF, so multi-annual financial framework of 1.1 trillion. So from these financing possibilities, I think the AM sector will be able to benefit through various channels, various EU programs, through the through the member states. But also we can go back to this during the Q&A session. We can go to the next slide. So I was saying that among the new things put on the table to increase resilience and strategic autonomy of in the context of following the lessons learned from the crisis, we have under Invest EU program a new, what we call, window. It is basically, it's about provisioning guarantees. So it's basically leveraging private investment in a number of strategic sectors and value chains, as I said, with the aim of increasing strategic autonomy and resilience. And here the eligible sectors are critical infrastructure, key enabling the transformative green and digital technologies, manufacturing and ICT components, and stockpiling, for instance, in critical value chains, for instance, health, and critical technologies. Here as well, I think this is relevant for the AM sector, because you are relevant for some of these sectors, which will be where investments will be supported through this new window. And then we can go to the next slide. Okay. So now, because I was reading the question, now we can speak a bit about how to increase the AM in the industrial value chain. We have seen actually also following the pandemic crisis, but also due to improved technologies, that there is a stronger take-up of 3D printing and 3D printing solutions. we also see that in the next 5 years there will be a further increase in such a take-up of 3D printing solutions because of costs, reduced costs, and because of ongoing increased improved technologies. And we have also, I wanted to flag one project we have, which is focused on SMEs and the access of SMEs to 3D printing solutions, and which could further improve actually the presence of the AM sector in the industrial value chains in Europe. So it's a project which is a European Parliament financed project, but is managed by the Commission. Its objective is to support SMEs in uptaking 3D printing solutions. It started last year, and we can go to the next slide actually. So it is its objective is to develop an online interfaces to connect 3D printing facility centers and SMEs. There is a call for proposal for SMEs actually with a deadline 31st of August. So maybe this is interesting to note. So you will find more information on the website, which I mentioned in the previous slide. And I think this might be interesting for your sector. Thank you very much. And yes, I think that maybe there are already quite some questions which I can try to answer later on.
Thank you very much for that. Thank you very much for that. We will now move on to Fabio, Global Head of Strategic Business Planning for Hewlett-Packard with respect to 3D. The floor is yours, Fabio.
Yeah, thanks, Stuart. Hello, everyone, and thanks for joining us today, and thanks to the Sesimo team for having me speak at this forum here today. So a couple of things before I start. You know, the introduction Stuart did that. My regular job on a day-to-day is to lead the strategy and planning for the 3D group at HP. But since mid-March and over the last few weeks, I had the honor and challenge to set up a global task force inside HP to leverage our technology to address some of the biggest challenges the world has been facing over the last few decades. And that was really centered around providing medical supplies and whatever support was needed to hospitals and health providers and communities around the world. So what I want to do today in the next 10 minutes is really to share a little bit some of the key learnings, the fundamental accomplishments and proof points that demonstrates the power of the additive manufacturing industry as a whole, okay, and what HP has accomplished, and also speak about some of the challenges we have faced and what can be done and be used from now on to ensure that the world becomes safer, more resilient, more agile and adaptable to moments of crisis. Okay, so the first thing, I just want to share some data points here. So some facts. So from an HP standpoint, but I'm sure this reflects the broader effort as well across the additive manufacturing community. I think the first thing was one of the key learnings, and was an impressive one, as we started this task force inside HP and we connected with several members of the additive manufacturing industry, was the power and passion and efforts that this whole industry put behind providing medical supplies to the world, right? And I have the data from HP only, but I'm sure when you look at the full additive manufacturing industry, the number is larger. But just from HP and our ecosystem, I think there are some impressive accomplishments. The first one is we have produced so far since mid-March more than 3 million medical supplies. And have given it to globally to communities. And this was part of it was everything that HP has produced from our initial from our manufacturing centers. We have donated all of it Several of our customers, more than 50 customers and partners around the world, have joined the HP efforts using our technology, have also donated or provided these at cost. Okay, and so pretty impressive numbers of supplies, and in a time of high shortage, it truly made a difference for the world, and it helped fundamentally save lives. Okay, this was accomplished through a couple of key things. One was, you know, from our own company, the people and the culture behind it. Within few days that we started the task force, we had almost 1,000 employees joining, volunteering for this. We made all the files available, as others have done across the industry. We made all the designs available and parts available to whoever could print and would print them and provide them. So it was really in a crisis mode, running against the time and making sure that we could provide the best support to whoever need that, right? And that was only possible because of the network of and passion of our customers and partners. Again, I said more than 50 of them, but there are several more. So huge, massive global effort. And in a matter of literally 2-3 weeks, we developed and made available more than 15 applications. And I will speak a little bit about what these applications are, what are the challenges we went through, and what it took to get to this stage. Okay, so all of these resulted, you know, it was very interesting, resulted in a lot of news and coverage, which fundamentally helped the 3D industry gain a lot of visibility across the world. Right? You see major newspapers highlighting what we have done. Some of them that would usually not cover 3D printing, but 3D printing really become mainstream in the news. Okay, our efforts, the industry efforts, so it really helped fundamentally raise the awareness, and I hope that it helps in the future to position 3D printing now with some of the data points and the number of parts we provided and some of the visibility as a true manufacturing technology that is scalable and can be repurposed and is agile and can help address some of the challenges the world faces. So I think this was a great proof point for what the technology can do, its readiness, and really positioning 3D printing finally as a true manufacturing technology. Then, you know, let's talk a little bit about what we did. You know? And so there are some of the key applications we worked on where, you know, we started with personal accessories. You can think Materialize, one of our key partners, developed the hands-free door opener. There were customers in China that developed mask adjusters, face mask adjusters, but then quickly we went to producing and, you know, designing and producing face shields, respirator components, CPAP components, all the way to swabs, and now the first approved N95 mask. So on this slide, what is a couple of key takeaways? You see that what we were able to do, you start from an idea. And then if you take the face shield, within 3 days, we were able to move to producing the face shields in thousands or tens of thousands within a matter of days. And so it really proved that 3D is very agile and flexible technology that can translate ideas into final products very quickly. Okay. Now, when you see the check mark there, and you see it's a bit far out, that's the regulatory approval. So although we're able to come up with the idea, work with hospitals very closely, design the most optimal face shield, and we started producing and shipping to hospitals. We did that in some cases without having the regulatory approvals in place. And so that was a little bit of the first learning we had. Couple of things we had to go through. One is understanding the regulatory landscape in this industry, because although the regulations were slightly adapted to accelerate the approval process, the fundamental requirements didn't change, right? So in a time of crisis, even if you're in crisis mode, yes, there were some benefits provided by the institutions, but more could be done to accelerate the regulatory approval. Okay. The other one is just the fundamental knowledge of the industry. Many in this industry, at least at HP, we didn't have knowledge of these applications. So sourcing the right skills and expertise doing that. And so this ties a little bit to what Stuart shared at the beginning about the key barriers to adoption. So on that talent gap, on that intellectual property, on that certification area, yes, these were fundamental challenges we had to go through, and some of them slowed down the adoption. And I would add another one that maybe was not captured there was the orchestration and organization at the Central European level and even at the country level that could have amplified the impact of 3D printing from what we have done today. Better coordination, better alignment across the AM industry, but also across countries and regulatory systems could have definitely helped us. So I think the slide you had, Stuart, was spot on some of the key challenges that you reflected as barriers to adoption. Some of the key learnings we got, right? So the first one I touched on was really this agile and very accelerated time from idea to production that 3D printing provides. Right. The second one is this power distributed manufacturing. At the end, as we developed these parts, we made files available on a website, and then hundreds of people started downloading them and printing them on MJF around the world. So a file was developed in Spain or in the US. It was within hours printed in France or Germany or Canada or somewhere else around the world. So that distribution manufacturing, that agility of the technology was really powerful, and that also enabled the power of the ecosystem and fundamentally enabled companies around the world to support their local communities. And so this repurposing of production on the spot, I think, is a fundamental capability that 3D printing provides, and it's probably the only manufacturing tool in the world that provides that. And it's gonna be a key tool for making the world more resilient in the future. The other couple of things that I think were very important and are more of soft benefits, I think, the growth mindset of the industry. What I mean by growth mindset, the ability to adjust, the ability to come up with ideas, validate and work closely with hospitals and health workers. And so the spirit of this industry and the people that make this industry was really amazing in taking this big challenge, stepping up and taking risks and providing support to the local communities was incredible. And so I think this speaks a lot about the innovative spirit that makes up the manufacturing industry. Okay. The last thing, just I want to show an example, a practical example of what happened during the crisis. I spoke about the face shield and the virtual world. Really on March 21st, we started working on a face shield, working with a local hospital in Barcelona, Hospital St. Paul. That was a Friday night. On Saturday and Sunday, the parts were tested and validated, and new design changes were made by working closely with the hospitals. On Monday, we were shipping the parts. Okay. On Tuesday, the parts were produced in San Diego, in the US as well. And so 2 weeks later, we were able to already ship out thousands of parts around the world of these face shields. So this really demonstrates the power of innovation and the power of this solution. Okay, and then the last slide I wanna use here, just for thought here a little bit, is really the repurposing capacity and agility of 3D printing. I touched on it during the presentation, but I think as the European Union focuses more on building a different economy in the future and supports the industry, I think this is some key considerations that need to be taken into account, not only from institutions, but also from private entities, the ability to bridge capacity in a very short time frame when traditional supply chains are disrupted, the flexibility of production that 3D printing provides, and then the ability to distribute and be adapting the supply chain. Really, you have one printer, you have 10 printers, you can place wherever you want. These solutions provide great flexibility in times of crisis and can really help solve real problems for the world. Okay, so I will stop here. I think I used my 10 minutes of time, and then I will take more questions later on.
Thank you very much for that, Fabio. I think that's a fantastic story, and I really appreciate you sharing it to us. Amazing. I will move on to our third speaker, Bernard Muller, who's a spokesman on behalf of the Fraunhofer AM Alliance. Bernard, welcome, and can I hand you the floor, please?
Thank you, Stuart. I hope everyone can hear me. So here we go. So this is the title slide as announced. So my talk today is about embedding additive manufacturing into industrial value chains. Let me start with a quick introduction to the Fraunhofer Additive Manufacturing Alliance. So I'm speaking to you today on behalf of 20 Fraunhofer institutes who are involved in applied R&D in terms of additive manufacturing. We are clustering our research into 5 main research topics, which is engineering. So it's about the products and solutions and the respective process chains. It's materials for additive manufacturing in terms of polymers, metals, and ceramics. It's about the AM technologies themselves. So laser-based, print-based, all the technologies out there. It's about quality, which is a very important thing for industrialization of AM. And the 5th research topic is software and simulation. So you see on the map of Germany where all the 20 member institutes are located. On the next slide, I will also have a short introduction into our pandemic fighting activities. Just a quick introduction. All of you have seen those face shields that have been 3D printed all over the world. Just one quick example from Fraunhofer, as the Johanniter Unfallhilfe, the German St. John's Order, who is having a lot of first responders who are in urgent need of face shields. And so there was a call from the German Medical Goes Additive platform and network to support this need of 5,000 face shields. And in a very short period of time, only about 2 weeks, and Fraunhofer was taking up the call and was able to provide more than 500 out of the 5,000, involving 6 of our 20 member institutes. And you see some impressions on the slide here. Another interesting approach to increase the output was by our colleagues from Fraunhofer IML. They have re-engineered an open source file for face shield to optimize that for polymer laser sintering. And as you can see in the picture here on top, they were more easy to stack. And so this way they were able to increase the output of one single laser sintering print shop from 60 to 500 face shields. And by doing this, they were themselves at IML able to provide 1,500 face shields, and they were providing the 3D file also open source for everybody to make use of that. So coming to the actual topic, so how can we embed additive manufacturing into industrial value chains? And there are several projects with Fraunhofer involvement, and 3 of them I would like to introduce to you. The first one is our Fraunhofer internal lighthouse project, Future AM. This has been started a couple of years ago, and it addresses main topics that are today's hurdles of real industrialization of additive manufacturing. It's about the digitalization of AM along the entire process chain, and it's about increase of build rates and of component sizes, and about in-process monitoring for quality control. It's about the increase of material diversity and also about multi-material processings in AM, and it's about the automation of the entire process chain, especially the post-processing. So if you look at the process chain from design through the manufacturing, heat treatment, post-machining, up to the finished part, it can be found that up to 70% sometimes of overall component costs are caused by post-processing. And so this was this is now a lot of manual work today for component removal, support structure removal, mechanical processing, and so on. And there is no integration yet in industrial manufacturing environments. So this is being addressed by this project. We are developing an autonomous manufacturing cell, which is aiming at reducing labor costs by 50%, production time by 50%, and post-processing costs by 70%. And it is including the entire post-processing from the powder removal to mechanical post-processing. And the part of component identification is quite a crucial one. I would tell you a little more about that, our activities in there. So 3D printing, additive manufacturing provides the possibility to integrate identification strategies into the component itself. And this has been addressed in the project. So you can see here, so you integrate the code into the component. You can read out later on, and the readout technologies are able to decode the data and assign them. So this is for many reasons. So clear allocation of component and production parameters. It's about traceability in different industry sectors. In many, it's required or even mandatory, like the medical. And it's also about fighting product piracy. So we were investigating different types of codes. They have been introduced into demonstrator geometries, in this case a hip stem from the medical sector. And 3 technologies have been investigated for readout. There's this one on the one hand eddy current, it's ultrasound, and it's computer tomography. At this stage, we are investigating with industry partners which of the technologies are most suitable and without causing any extra time in the process chain. So we don't want to lose time by a readout of information along the digital process chain. So the industrial requirements are right now in focus of the further development within that project. If you're interested in that, please contact me or my colleague Markus Oettel. We are still searching for industry partners providing us with their requirements. Another example on also with a link to Corona or any other type of crisis is this project from our member colleagues from IFPT. It's about the development of a mobile production line for medical equipment facilities in crisis regions. So this addresses 3 stages: the data management specifically for those medical equipment parts, for example, face shield components, but can be also others. It's about the on-site production in the crisis region using augmented reality and also using a container format to easily transfer this unit to any place in the world. And it's also supposed to provide quality assurance tools like QR codes, also augmented reality supported part checking, up to sterilization and packaging, which is important to have output of medical equipment in the state that is needed in hospitals and so on. The two last projects I would like to share with you are the projects that are funded by the German Federal Ministry of Education and Research in their call on industrialization of additive manufacturing. The first one is called IDEA, Industrialization and Digital Engineering Additive Manufacturing. This is focusing on metal additive manufacturing. It's a large consortium of industry partners and research institutions. And as you can see here in the entire process chain, all the individual process steps from design and modeling to the final part control. Today, it has to be stated that it's mostly isolated today, large number of manual operations, and this project is addressing to really integrate this into a production line for additive manufacturing, and in the end, addressing all the needs of a real industrial production. So the focus of our colleagues from Fraunhofer involved in here are on automated component handling and support structure removal and process chain evaluation, as you can see here. So component handling is very crucial, as we also found out in the Future AM project I was introducing to you earlier. So it's about to develop a methodology about this. Regarding the support structure removal, it's about software development. How can we easily address the removal, mainly CNC based, of the specific typical support structure for metal AM components. And the third part is the software for the automated process chain evaluation. The second project, which is very similar, as you can see also here in the target description, to the IDEA project, is the Polyline project. As name addresses, it's about polymer additive manufacturing. The consortium is similarly large, and so this is addressing the same issues. It's the vertical and horizontal integration of AM processes today is lacking. The industrial needs and the standardization. So we are today talking of a batch-like process and low level of automation, and a lot of manual and physical handling of transport processes. And this is all addressed in that project specifically for polymer AM, specifically laser sintering. The next slide also underlines our research activities in here. Our Fraunhofer IML colleagues are focusing on the integration, on an integration concept, the basic one, and on the material flow. They are material flow specialists, and the specifics of the AM material flow are addressed in that project. The colleagues from Fraunhofer IGCB are focusing the digital process chain, and concepts for that, and not last but not least, also the quality and the technical cleanliness, which is a very important issue in conventional manufacturing, and this also has to be addressed for additive manufacturing. Cleanliness of products is crucial. So once again, if you're interested, contact our colleagues involved directly here. And to leave some time also for Vincent, I would like to stop here, and hopefully I'm able to answer some of your questions later. Thank you.
Thank you very much, Bernard. I'm going to move immediately on to Vincent Venegar from REM Lab, to our final speaker today, before a few questions and a summing up at the end. So straight over to you, please, Vincent. Thank you.
Yeah, sure. I'm Vincent Wegener, Managing Director of REM Lab, also co-founder of REM Lab. interestingly, we started a few years ago with the observation that the world is actually rapidly deglobalizing, and we spotted a few trends, key drivers that were causing that deglobalization. So it's protectionism, digitization, decarbonization, and this made us wonder here in the Port of Rotterdam what we can do about it. But then, of course, an accelerator came along this year, which I think is accelerating the deglobalization with COVID-19. So we here in the Port of Rotterdam, REM Lab is funded by the Port of Rotterdam Authority, did an exercise a few years ago with what happens with the ports of the world when we no longer ship goods to one another. What's then the function? So that was one of the key reasons why the Port of Rotterdam decided to invest in setting up REM Lab, which stands for Rotterdam Additive Manufacturing Lab. And we can see that today, actually a glimpse of the future, because we saw that there was a drop of 20 to 30% in shipments here in the port, and also, of course, a huge decline in consumption of oil goods like kerosene. So it gives us an idea of what will happen if we continue with digitization, decarbonization. So we started a few years ago with the mission of let's see if the next slide comes up. Too fast. All right, so a few years ago, we started to focus on wire arc additive manufacturing, because we currently see the problem where the current machines out there cannot make large parts. So that's the main reason why we started with wire arc additive manufacturing. Three of the benefits of wire arc additive manufacturing is that it's relatively inexpensive machine, because you basically use a welding system. You can do a lot of kilos an hour, which is important if you want to make big parts, and also the quality is excellent compared to, for instance, casting. So in 2017, we were able to print the first propeller in the world, which was the WAM propeller, as we called it. We were able to print it in about 10 days straight, which was about 300 kilos. And that was an R&D project. If we would do it again, I think we could do it in 5 days, more or less. So it really shows you can make parts, large parts, on demand and locally. And we also got the certificate from Bureau Veritas, so it was really officially certified. And more importantly, of course, for us, it was also officially amazing by the Guinness Book of World Records in 2019. So looking at wire arc additive manufacturing compared to casting, we see that it's far better, superior quality, because it has more refined microstructure. And it's also an increase in corrosion performance, and we see a better tensile strength than casting. So it's one of the reasons to look if we can do more with WAM than with casting, especially when most of the casted parts are coming outside of Europe. We also did a study on another part. This is an impeller, where we again went from design to modeling to manufacturing within a week. Another study we did was a ship bow. This is normally a fully solid part that is milled from 120 kilos to 60 kilos. But in the end, you only need a shell, as you can see here. So we reduced it to 6 kilos. And also it can be made locally. It takes about a day to print. So it takes away all the need for sourcing, which could take up to a month or two. Another study we did for the Port of Rotterdam is more into hybrid manufacturing. So we of course have a lot of boulders here. They break down once in a while, and then they have to be ordered. They come from Asia. They're costed over there. It takes time. So we looked into what can be done to manufacture these parts locally, and then specifically what can we do to prevent print time or reduce print time. And this is one of the ways. So that's one of the benefits of WAM, is that you can actually produce hybrid parts where you take a standard off-the-shelf tube and you print the complexity on top of it. And one of the other parts we're working on together with an offshore company here based in Rotterdam is a hollow hook. So normally when you cast a propeller or you cast a hook, it's completely solid. And that's not necessary. You can reduce weight actually also of a hook by making it hollow. But it's impossible to do that with casting, but you can do that with 3D printing. So together with partners here from we started with partners here in the region, but we now have a consortium of many European companies, and together with them we're researching how we can accelerate the development of wire arc additive manufacturing. So we have software providers, consumable providers, hardware providers. Of course, we work together with academic partners to push the technology towards commercialization and wide adoption here in Europe. So one of the ways we do that is to have a large research program here in the Netherlands where we focus on property on demand, so making parts that actually have certain properties that are better, like I mentioned, for instance, than casting. On a European scale, we have been leading a consortium which is called Grade to Excel. And Grade to Excel is focused on multi-materials. So one of the benefits of the technology is that you can actually use multiple materials. For instance, a propeller where you have the inside made out of a relatively cheap material, and then only the outside is cladded, for instance, with a more durable, corrosion-resistant material. This is done with a consortium, as you can see, throughout Europe, and we just started this year. But the main objective also of this project is to spread the adoption of this technology, mainly for SMEs. So also SMEs will be able, after this project, to print parts and print multi-material parts. And then lastly, we are also working, as mentioned before, but it's also the digitization is of course a very important part to reduce the reliability of warehousing, moving goods all over the world. Of course, the Port of Rotterdam is one. There are many warehouses here, and studies have shown that many parts are basically shipped all over the world and then thrown away. So it's just lying there for years and then scrapped, which is of course a waste. So we should move to a digital warehouse, so we can make parts locally and on demand. We are involved with DNVGL. They just set up a joint industry project where we've taken part of, and then we also helped with writing the standard for additive manufacturing of metallic parts, and specifically wire arc additive manufacturing, because without certification, without standardization, indeed adoption of additive manufacturing will take longer. So it's important to also invest time in that. And with that, I thank you for your time, and this was my presentation. Thank you.
Thank you very much, Vincent. Very nice presentation and some nice applications. We've got a few minutes left to questions. I'm willing to overrun if anyone else is. I'll leave that to the Sesimo team. Can I hand the floor to you, Vincenzo, to put those questions to the panel, please?
Absolutely. So first of all, apologies for the small technical delay. Let's say the screen decided to freeze in the worst moment. Now we have some few minutes now, of course, to address some of the questions that you posed, but make sure if your question is not asked, to send it back to the Sesimo team so that we will address it directly to the speakers. We have a few questions for let's say for Lorena Ionita. First of all, there is someone from a startup from the Netherlands that their solution fits in the game-changing innovation approach. They are creating an IP protection of digital files that allow licensing and traceability. And they want to know what kind of, let's say, financial support is the Commission providing for startups that are launching new ideas in the digital manufacturing world.
So I think in this case, for instance, the new investment window under InvestEU I mentioned could be one possibility, but these are of course this InvestEU, it's guarantees. So basically it's provisioning of guarantees in the EU budget, and these projects are being financed by the European Investment Bank and national promotional banks. So the projects need to be bankable, so to be able to be eligible under InvestEU. Also, in these digital technologies, we have the Digital Europe program, also, which is an EU program, and there could be financial possibilities there. And as it's a startup, we also have specific programs, and actually this again, we have a startup initiative, and also this is again my colleagues from DG Connect. So they are dealing with the digital files, and they're under startup initiative. We can also finance startups. So there are various programs depending on the angle we take.
Thank you.
And of course, some of them are, I mean, loans, and in other programs you can like InvestEU, but in other you can have grants, which maybe it's more interesting because yeah, you don't have to pay the money back.
Thank you. I have a question for Fabio Annunziata, and in particular, one of our attendees it's asking if, in your opinion, what other sector, in your opinion, could learn from this experience and let's say make their supply chain more resilient, let's say, with the use of additive manufacturing.
Yeah, I think that's a good question. I think the medical obviously is one, right? I think there are other critical industries that have faced significant disruption. You go from automotive to industrial equipments, but pretty much everything that has centralized supply chains in specific locations, be it China, Germany, or South America. I think the world is moving to a much more decentralized production environment. And so whenever you have these centralization of supply chains today, what happened through COVID is this fundamental disruption of supply chains and the inability to move goods from one place to the other. I think 3D printing now has the opportunity to really make an impact and become a tool that can close these gaps and avoid these significant disruptions in supply chains.
Thank you. We have a question for Vincent. One of the participants is wondering if there are any parts printed at REM Lab that are used then in the aerospace sector.
Well, we're involved with GK and Fokker. They're one of our partners as well. So their interest is, for instance, in the sector of in the part of making molds, mold making, tool making, and then we're also involved in a project for titanium printing. So that's also a popular topic in the aerospace sector, of course, to reduce the amount of titanium, which is normally milled. So we are now involved in a project to print those parts.
Thank you. And from again, now I have a question for you, Bernard. And in particular, well, let's say, what are the first steps that a company should take in order to properly integrate additive manufacturing in their supply chain, according to your experience, of course?
Well, we believe that many companies are following an approach like starting up with additive manufacturing in buying a machine and appointing 1 or 2 people who are trying to do business on that machine, and we have seen many failures in that approach. And so our recommendation would be to first of all really focus on getting in contact with experts on additive manufacturing and analyzing their internal process chains, their current value chains, identifying potential applications, potential products, and then together with experts, not necessarily from Fraunhofer, but maybe also from Fraunhofer, to address those potential applications, to introduce the technology on a theory base, so to give input to their staff, to the engineers, and to take them on the journey and to start up not by buying a machine and do a trial and error prototype or part manufacturing, but really do it from scratch and really look into the technology and get a lot of input from experts, from outside experts who know about additive manufacturing.
Thank you. As I mentioned before, we have received several questions, so I would really invite, we will of course note them down, but I will invite all the people that have sent us those questions to get in touch with the Sesimo team, because we will make sure to answer to you and to forward your questions directly to our speakers. And since we are a little bit behind schedule, I would like to hand over the mic to Stuart for the final remarks and conclusion. And from my side, thanks to all of you speakers for participating.
Okay, thank you for that, Vincenzo. Thank you once again to all the participants, speakers today. If I just briefly run through what we noted and discussed. I mean, first of all, I'd just like to say that I thought that the reaction by the AM industry and community to the challenges of COVID has been absolutely fantastic, and seeing some of the responses, the networks, the new ways of working. What a way! If we touch on Anita's speech today, the importance of the sector, the funding available for industry, the amount of funding to get back from the bottom of this pandemic, the 3 pillars of recovery, clearly an enormous amount of work to do and an awful amount of funding needed. But there is funding out there for the industry, and I implore you to take advantage of it. There's also an awful lot of work goes on behind the scenes to implore our politicians to provide this funding. So please take advantage as an industry. Fabio, a great example of a company reacting to a crisis and developing a number of parts and applications extremely quickly. I did see on the message boards earlier someone saying, can you please give us concrete examples of part substitution using 3D printing, and we will endeavour to get back to you on that question, because I appreciate that's a very important one to answer. Apologies for not touching on it now. We also looked at the Fraunhofer, some of the projects ongoing to take cost out of the technology, to scale it and improve its industrialization. As ever, the Fraunhofer doing some fantastic work on the sector. And then finally, I thought a really interesting presentation from Vincent on decentralization, deglobalization. I think that the geopolitical situation is changing almost on a daily basis at the moment, despite the pandemic, and some very interesting examples of the use of AM technology to replace traditional ones. So thank you very much. Thank you very much for their participation today. I'm hoping that we will be able to have more of these webinars in the future. I hope that the audience found that useful today, and we look forward to hopefully, if not seeing you, but talking to you at some time soon in the future.